Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Social Sciences, SOSS. Postgraduate Diploma in Disaster Risk Reduction and Management, PGDDRRM. MPA031 Physical Geography. Block-1 Geomorphic Processes. Unit-6 Aeolian and Coastal Landscapes, 6.0 Objectives. After studying this unit, you should be able to describe the meaning and concept of Aeolian and coastal landscapes. Explain the mechanism of erosional and depositional process. And discuss the erosional and depositional features developed by wind and sea waves. 6.1 Introduction. In previous Unit 5, you have studied about the fluvial, karst and glacial landscapes. In this unit, you will study about the Aeolian and coastal landscapes. Aeolian and coastal landscapes are developed in two distinct geographical, climatic regions. Aeolian landscapes are found in arid and semi-arid regions. In this type of areas, precipitation is very minimal. They are located in the subtropical high areas of the globe. Details of the climatic conditions and pressure belts are dealt in Unit 9 of Block 2, Atmospheric Processes. Coastal landscape is confined in a narrow belt along the coasts of the ocean. The landforms produced in these two regions are quite distinct. 6.2 Aeolian landscapes. Arid and semi-arid regions are characterized by the annual rainfall of less than 50 cms. In such condition, air remains dry. Wind and running water are the two agents working in hot desert regions. But due to special geographical locations and climatic conditions, wind remains the dominant erosional agent. In hot desert regions, sometimes, rainfall occurs, but due to intense evaporation, their effect becomes very limited. The landscape develops in arid or semi-arid regions are also called arid landscape. Physical weathering is more dominant in the region. Erosional and depositional processes are active in hot desert regions. Hence, the landforms created in arid region are grouped into two erosional and depositional. 6.2.1 Erosional landscapes. Several topographies are developed in hot desert regions by prevailing wind. The dry winds blowing in deserts contain sand particles. When any rock obstacle comes in the path of prevailing wind, they work like a sandpaper on that rock. Different types of special landforms are developed like Gara, Yardang, Zugan, Demoiselle, Wind Window, Aeolian Bridge, Inselberg and Petty Plain are prominent among them. Gara, mushroom rock. The name itself explains about the shape of the topography. It looks like a mushroom. When the prevailing wind active over a rock from one direction, throughout the year in hot desert region, the rock is eroded by wind action. Since the wind is more active at the surface, it is eroded more near the surface. The upper part of the rock is projected towards the wind direction. If the direction of the prevailing wind changes with the season, or it is active from different direction, then the rock concerned will look like a banyan tree, popularly known as mushroom rock, Fig. 6.1. It is worth mentioning here is that the sand, silt carrying capacity of the wind in desert regions is up to 30 meters. Hence, the lower part is eroded and the upper part is unaffected. It is large and wide in comparison to the lower part. Therefore, the rock looks like a canopy. Look at the screen. Fig. 6.1. Mushroom rock. Source, author. Yardang. In desert regions, the alternate arrangement of hard and soft rocks found vertically in the path of prevailing wind direction creates yardang. The columns of soft rocks are eroded easily and quickly in comparison to those of hard rock columns. After a long time, the column of soft rocks is converted into small depression due to wind erosion and removal of eroded particles. The hard rock column stands above as ridges. The series of depressions and ridges are known as yardang. Fig. 6.2. Yardang. Source, author. Zugan. Zugan is also called inkpot-shaped topography. It is developed in hot desert regions, when alternate arrangements of hard and soft rocks are found horizontally. Once the horizontal hard layer of rock is eroded, the Lower soft layer is eroded easily and quickly. Even undercarving is also done. In the softer rock by wind action. It resembles an inkpot. Fig. 6.3, Zugan, source, author. Yardang and Zugan both look sometimes almost similar, but they do have differences. Yardang develops on hard and soft rock found alternately and vertically, while Zugan is formed on different resistant rock found horizontally. Demoiselle, when hard rock is found on the top and soft rock lays underneath. Differential erosion by winds in dry region creates a pillar-like structure. Once the top horizontal hard rock layer is removed with a cap on top, the surrounding soft rock is quickly eroded and an earth pillar is created. It is known as demoiselle. Wind lattice, window and wind bridge. Window and bridge created by winds are the result of special type of sock found in the path of prevailing wind. When the rock made with mixed resistance mineral is found in the prevailing wind direction in hot desert region, wind codes the soft mineral rock particles very quickly and easily. In this way, several holes are made in such rock. The several holes in a rock look like a lattice, hence, it is called wind lattice. Fig. 65. When two or more than two holes mixed with each other and creates a larger hole, wind passes through these holes are known as wind window. Fig. 6.5. After some times, these several windows are merged and create one and single large window is formed. Such large window looks like an arch-like structure. This structure, through wind passes, is called wind bridge. Fig. 6.5, look at the screen. Fig. 6.5, wind lats, window and wind bridge. Source. Author. Pedoplane and Inselberg podyplane is a flat erosional surface created by wind in its last stage of an cycle. It is characterized by featureless plain with minimum relief in the concaved area. Most of the coated sand and silt particles are removed and big-sized boulders are left behind. Hence, surface covered with boulders in deserts are known as pediments. Therefore, paraplane is formed by coalescence of several pediments. This boulders-covered low-laying featureless plain is known as pedyplane. Fig. 6.6. The hard resistant rock in desert region is seen as hillocks in almost featureless plain made by wind action. Popularly termed as end product of arid cycle of erosion. Hence, the hillocks in the podyplane are known as Inselberg. Fig. 6.6. Fig. 6.6, podyplane and Lulberg. Source, author. 6.2.2 Depositional landscapes. All the agents of erosion transport the eroded materials. These materials are the tools to perform its corrosive function. The ability to transport is also governed by several factors. Once the ability to transport the material is reduced, the same is deposited. The way a transported material by wind is deposited, several types of landforms are produced. Important among them are sand dunes, barchans, safe, sand levees and loess. Sand dunes are depositional landform. For the development of any depositional landscape in hot desert region, an obstacle of rock mass or shrubs is needed in the direction of the prevailing wind. In such condition, wind deposits the carrying sand along the axis of the obstacle. Thus, a mound of sand created is known as sand dunes. Fig. 6.7. The slope of sand dune is gentle towards windward side and steeper towards leeward side. Sand dune is a temporary landform found in the hot desert and it migrates forward in the direction of wind. It happens due to the absence of compactness among sand particles in dry environment. Sand dunes are of two types: transverse and longitudinal and dunes. Look at the screen. Fig. 6.7, sand dunes. Source, author. Barchan. Transverse sand dunes are called barches. It is crescent-shaped topography develops due to the presence of obstacle. Here the role of wind is prominent in shaping the barchans. When sand is deposited in front of obstacle, the prevailing wind snatched them from the sides of the obstacle. Hence, the horns are developed from both sides of sand accumulation. Such topography is termed as barchans. Fig. 6.8. Windward slope is convex in shape while leeward slope is concave. On concave side, sand is accumulated on top and falls slips downward. It creates eddy due to which sand is accumulated and horn of barchan is elongated. Fig. 6.8. Barchans. Safe. Longitudinal dunes are called safe. They are long, narrow chain of dunes created by sand accumulation. This accumulation is in the direction of prevailing wind. Due to crosswinds, safe height and width is increased while winds parallel to their axis cause them to enlarge in length. It is also developed due to lengthening of Barchan's horns. Basically safe or higher ridge of sand accumulation. The land between two safe is a lower depression. It is almost sand-free. It is used for movement in the desert as walking is relatively easy. It is called as gassy. Loess. The wind takes away fine sand particles thousands of kilometers far from the deserts. When the carrying capacity of wind becomes negligible, the sand particles tend to settle down. Thus, a plain is formed known as loess. Loess deposits may become very thick in due course of time. In northern China, loess plain is found. According to Pi, 4 fundamental requirements are necessary for the formation of loess: a dusty source, adequate wind energy to transport the dust, a suitable accumulation area, and a sufficient amount of time. 6.2.3 Waterborne depositional landscapes. The running water also works as an important agent of denudation in some of hot desert region. Just like humid region, running water performs its action in hot desert region as well. Since physical weathering is very high in hot deserts, an easily available tool for running water erodes very quickly. Large quantity of available sediment also gets deposited as the available water is also not in large quantity for longer duration. Hence, water-derived depositional features are seen in the desert region. Playas or salina. After rainfall, a temporary lake is formed. This type of lake is termed as playas or salina. Fig. 6.9. Some intermittent streams provide water to this lake. The lake region is like a depression where water gets deposited. Since temperature is very high, the accumulated water gets dried. Due to high evaporation, salt is deposited there. That is why playa is known as salina. When the water of Playa Lake dried due to high evaporation, the salty layer can be seen on the surface. Bajada. When water flows from the upland in the desert, large quantity of gravel material is transported and gets deposited at the base. The deposited materials give rise to form a fan-shaped deposit. When several fan-shaped deposits merged, it is called as bajada. Fig. 6.9. Bajada is also termed as balsan. Fig. 6.9. Pediment. It is a low-slope erosional surface with low relief formed in the desert and semi-desert by running water. It is formed at the base of a receding mountain front. It is generally associated with parallel retreat of slope near the mountain base in deserts. The pediment is covered by thin and discontinuous soil, alluvium or colluvium. 6.3 Coastal landscapes. Sea waves play an important role in the development of coastal landscape. Its impact is seen near coastal regions. That's why the landscape developed on coastal zone are called coastal landscapes. Generally, erosional topographies are developed on upper part, landside, whereas depositional topographies can be seen in the lower part, towards seawater of the coast. Corrosion or solution, abrasion, attrition and hydraulic actions are responsible for the erosional work done by sea waves. The impact of these mechanisms depends on the size and energy of the sea waves, slope of the coastal region, height of the coast, structure of the coastal rocks, dip of the rock, and the depth of the seawater on coast. All these factors are altogether responsible for the development of coastal erosional and depositional landscapes. The features produced by sea waves are grouped into 2: erosional and depositional. 6.3.1 Erosional landscapes. Sea cliff. Sea cliffs are erosional landform created by destructive sea waves. Sea waves are generally caused by blowing winds over the seas. When wind blows, it generates pressure on the water surface. Wind blowing with pressure creates friction on the water and thus, water is pushed forward in wind direction. It results sea waves. Continuous striking of sea waves on its coast lead to massive erosion. Due to erosion on the coast, almost vertical, wall-like structure is created. This is termed sea cliff. Initially, undercutting is performed. The rocks laying above the undercut base is broken due to heavy weight. In this way, sea cliffs are continuously on retreat and land area is consumed by sea. Fig. 6.10, Sea cliff. Look at the screen. Wave cut platform. The formation of wave cut platform is associated with sea cliff. The sea cliff tends to retreats due to erosion as mentioned above. It keeps on retreating. In this way, continental shelf tends to increase accordingly. At the base of the sea cliff, wave cut notch, undercut is created. The surface between high tide and low tide is known as wave cut platform. Fig. 6.11. The width of the platform depends on how much the cliff has retreated. Sea cave severe formed along the coast by wave action when any joint found acting the secliff where the sea waves strike. Sea cave is formed when waves hit the whack zone of joint, it is broken and enlarged. In this way, its enlargement leads to form the sea cave. Numerous caves are found along the coast. Fig. 6. 12 Painted Care, Santa Cruz Island, Channel Islands National Park, California. Source: NPS image. Sea arch. Sometimes a narrow strip of landmass is projected towards sea. On this landmass, when sea waves strike, a cave is created. The cave is enlarged and a passage is formed so that the waves cross through it. This page is known as sea arch. Caves and arches will continue to form as waves coat more of the bedrock. Fig. 6.14. Development of sea cave search. Other. Stack. Due to weathering and erosion of the roof of the sea arch, roof is collapsed. Seaside pillar-like structure is detached from the mainland. It remains isolated. It is known as stack. Sometime, it looks like an island. This topography is also called as stack or chimney. At Dhanushkodi near Rameshwaram, you can see such stack. Near Dwaraka on western coast of India, you can see the stack. Bay and Gulf are erosional landscapes formed due to alternate arrangement of hard and soft rocks. When there is an arrangement of hard and soft rocks in vertical position, then the sea waves erode the soft rock comparatively easily. Hence, water intrudes into that eroded part. The hard rock comparatively projected towards the sea. This topography is known as bay. You can observe this topography on the eastern side of India as Bay of Bengal. On the other hand, when the alternate arrangements of hard and soft rocks are found in horizontal position, Gulf is formed. It happens when the hard rock is towards the sea and softer rocks are towards landside. The sea waves firstly erode the hard rock facing sea. Once the hard rock is eroded, softer rocks get eroded quickly. In this way a big cavity is formed in the softer rock region. Meanwhile, the outer, towards sea, hard rock is eroded slowly and a narrow mouth is created. The seawater intrudes in the cavity. Such inland intrusion of sea is popularly known as Gulf. 6.3.2 Depositional landscapes. When sea waves come towards the shore, they get friction due to shallow water depth. With relatively less force, waves strike the shore and erosion as well deposition is observed. We have already talked about the erosional landforms above. When water retreats towards sea, it brings the eroded materials towards sea. Due to lower capacity to transport, materials are deposited in different ways. Depending upon the ways of deposition, several landforms are formed. Let us discuss about them. Sea beach. Sea beach is a depositional landform formed by sea waves found along the shorelines. They are located between high tide and low tide zone. Continuous striking of sea waves along the coast generates sand particles. Those sand particles are deposited where the wave is not very strong as well. The sea is not very deep. Shallow water at the coast reduces the wave's energy, and the sand is deposited. Strong wave and deep sea drag the sand towards the sea, and beach is not formed. Where the slope is relatively high and waves are strong, gravel beach is found as the bigger sized boulders, gravels are left behind and smaller particles are brought inside the sea. Hence, there are two types of beaches: sand beach and gravel beach. Sand beach is found in bays, where water is shallow and has less wave energy. Gravel, pebble beaches are along the sea cliff where wave energy is more. Sandbars and spits, it is a depositional landscape seen during low tides. Parallel to the coast, sandbars are like embankment made of sand. They are found almost parallel to the coast. The shallow sea is found between sandbars and coast. There is no connection between coast and sandbars. When the one side of sandbar is connected to coast and other side is projected towards sea, such embankment of sand is known as spit. The mainland or continental part should be projected towards the sea as necessary for the development of spit. Look at the screen. Fig. 6.15, Sandbar and Spit. Source, author. There are three types of sandbar: a connecting bar, B. loop bar, C. tombolo. Connecting bar. Some bars are developed near narrower coast. It happens when sea is intruded towards land. The two sides of intruded coast get connected by sandbar a little away from inner part. This type is called connecting bar. You can observe the connecting bars near Ernakulam on Kerala coast. Loop bar. Some bars are developed parallel but around an island. It takes the shape of a ring, hence is known as loop bar or ring bar. Fig. 6.16, Connecting bar and loop bar. Source, author. Tombolo. If an island near the mainland is connected by a sandbar, it is known as tombolo. Look at the screen. Fig. 6.17, Tombolo. Source, author. Spits are also of three types. D. Simple spit. E. Hook spit. F. Looped spit. Simple spit. Simple spit is a sandbar deposit from the mainland extending towards sea in almost straight direction. The sea waves coming from both the sides of spit are of similar type in terms of direction and energy. That is why its direction is maintained almost straight. Fig. 6.18, Simple spit. Source, author. Hook spit. Change in the direction of prevailing wind is reflected by the change in the direction of the spit. Generally, the exterior part, towards sea, of the spit is turned marginally and it keeps on turning with passage of time. This turn is termed as hook. Looped spit, when the hook is turned in such a manner, so that it touches the mainland or about, named as looped spit. More than one hook spit is found in a spit, known as mixed spit. Such spit is develops due to effect of the change in wave direction. Mixed spit gives the evidences of climate change. There is no outlet found in spit. When the height of the bars and spit is above sea level, then it is called sand barriers. Thus, with the above description, it is clear that different types of erosional and depositional landscapes are developed by sea waves. 6.4 Conclusion. Aeolian and coastal landscapes are developed in two different regions. Aeolian landscapes are developed in hot desert regions lying in arid or semi-arid regions of the world. They are found in the western part of the continents, between 150-300 latitudes. Geographically, it is offshore wind region. Such region receives annual rainfall of less than 50 centimeters. Here, the air, wind, remains dry, and evaporation level is high. Therefore, wind becomes the strong erosional agent in such regions. With the help of abrasion, attrition, deflation and transportation process, different types of topography are developed in which some are erosional and some are depositional. It is worth mentioning here is that in oasis regions some waterborne landscapes are also develops. Coastal regions are found in different parts of the world. Here, the sea wave, or oceanic wave work as a strong denudational agent. The structure of the rock, slope of the rock and many other factors like solution, abrasion, attrition, and hydraulic actions are responsible for the erosional work done by sea waves. The impact of these mechanisms depends on the size and energy of the sea waves, height of the coast, dip of the rock, and the depth of the sea water on coast. All these factors are altogether responsible for the development of coastal erosional as well as depositional landforms. See you. Thank you.